Since we understand about the Cartesian product as well as the connection between Cartesian product and the join, it is time for us to see how do we use join operations to get the information that we are interested in that lies in multiple tables. So join, let's take a look at this example. Find the name of the employee who has dependents. And therefore, if you looked into the dependent table, you will be able to see that there are actually 3 people that has the dependent. One has 3 dependents, the other one has only Abner, and the last one has another 3 dependents. Therefore, in order to answer the questions that are asking in this slide, we need the name of those 3 employees. And that's why we need to join the table of the dependent with the employee table. Ideally, similar to what we have discussed earlier, we want to find a name that this exact employee, we want to append that employee's information in back of here so that we will be able to get the name of that employee. And therefore, what we would need to do is basically say select, instead of start, which means everything. Now we only interested in the first name and last name. That can give us a much more specific table, precise table that we are interested in. While we try to join the 2 tables, it's the same thing from employee as well as the dependent table, using a comma to separate the 2, indicating we want to do the Cartesian product of the 2 tables, and then add the where condition to make sure we only get the information that we are interested in, which is the social security number equals to ESSN. So that when we try to run this code, you can see that we will be able to get a table of this just first name and the last name with those 3 people listed over there. Let's take a look at the execution of the code in Oracle. So when we try to copy and paste and hit enter, you can see that you will get exactly the same tables I provided over there. You may have a question saying that, hey, wait a minute, I think there are some duplications. By definition of the database, these kind of things should not happen. So the answer is that's true. In the idea of the database, you should not have 2 tuples have exactly the same information. But you need to understand that Oracle is simply trying to output the information you are asking. If you want to make that happen, which means that you don't want to have any tuples that have duplications, then we need to use another reserved word called distinct. This distinct will actually give you the full probabilities of the database idea. So instead of just select first name and last name, now we simply say select distinct first name and last name from employee dependent where SSN equal to ESSN. What you will be able to get is the one that has no duplications. And of course, this is going to be very useful if you are interested in those precise informations. And usually we want to add that distinct reserved word over there. Therefore, using the same concept, if we want to make things a little bit spicier, so say now instead of finding the name of the employees who have dependents, now we want the name of female employees who has the dependent. In this case, it's actually pretty straightforward. In this case, we will keep everything still stays the same. Select distinct first name, last name from employee and dependent where social security number equal to ESSN until this part. This is exactly the same with what we have seen in the previous question. And now, since we only want the female employees, we can simply add more additional information, additional conditions over here using AND operation, and employee.sex equals to female. There are 2 special things I want you guys to see. The reason, again, I'm using employee.sex is because in the dependent, there's also a sex attribute, and therefore, by providing employee.sex it's very precise for the Oracle to see which attribute you want it to be, and the condition is saying that equals to F, which is female. If you don't do that employee dot, then the Oracle will give you an error message indicating I have no idea which one you're talking, which attribute. There are two attributes, both of them called sex. And therefore, let's try this. Of course, after the operation, you will see there's only one female employee who is dependent, who is Jennifer. And therefore, you can see that if we try to copy and paste the whole code without the semicolon, so that I will be able to control it. So if we're going to put that, saying that I put a semicolon over here and then hit the enter, run the code, well, you can see that Jennifer is the only employee that is a female employee with dependent. Now, if I don't do employee.sex, let's see what is going to happen. So in this case, I hit semicolon. You can see that it says there's an ambiguity over here. And therefore, if you see this error message, you need to understand how to debug it. So it's I have a star underline, sex, indicating that there's ambiguity not defined, and therefore we need to solve the problem. The other detail I want to show you is this. The quote here is actually the quote that Oracle can use. If you type in, say, Word document or PowerPoint, I want you guys to see that if I put additional quote over here, you can see this quote is actually very different from that quote. So if we type in things and copy paste in from Word, PowerPoint into the Oracle, it's actually going to give you error message. And therefore, that's something you want to pay attention to. That's the mistake that you don't want it to be. And therefore, you can see that's a different quote, single quote that Oracle is very sensitive. So join condition. So now you should understand join operation is a sequence of Cartesian product first to create a table that has all possibilities over there, and then you use the where condition to filter things that you don't want and keep the tuples that you are interested in. So this operation is super important for any relational database with more than a single relation, because as long as it has more than one table, you need to join the tables together and then get some information from that. And therefore, by definition, if we look into the join operation, we actually have in relational algebra, we have a notation to represent that. This is like the butterfly or bow tie representation providing the join conditions. This is something just for you to see. In Oracle, we don't really using this. We basically can see that we put the Cartesian product, two tables or more in the from command, and then use the where condition to provide our join operation. So when we do a join operation, we still get a table that has n plus m attributes. This part is the same with the Cartesian product. Of course, we can select only the attributes we are interested in to get a more simpler, easier to read table. The result after the select condition, the number of tuples are usually less than the tuples in the first table multiply the tuples in the second table. Of course, that's the general case scenario. After the join condition that you provide, you should filter out a lot of those informations. This join condition can be anything. You can write something totally weird, totally meaningless, and you will end up with the same results with the Cartesian product. That's why it says it's usually less than the number of tuples multiplied together of the two tables. So the equal join condition is a join condition with where conditions that provide the join conditions. So the equal join is a join with a join condition involving common columns from two tables. And you can see this is the general syntax about the join operations. And therefore, I want you guys to see a very important comparison between the two queries. Let's take a look at the first one. Find out the name of employees who work for department number 5. You should be familiar with these questions already because this is like the assignment or the homework practice that you have seen in the previous video. So when we try to do that, we can look into the employee table because it has a DNO attribute indicating that which department they works for. And therefore, since we simply say who works for department number 5, we have that information over here already. So we can simply say that select first name, last name from single table employee where DNO equals to 5. So you can see the first question is way easier than the second one. Now let's take a look at the second one. Find out the name of the employees who works for research department. Now I want you guys to see the difference. If you simply focusing on the employee table, which means that you select from employee table only, you have this table only. This table has nowhere tell you about research. So you cannot find any research information over here, and therefore getting the result from this simple single employee table is not going to be sufficient. Therefore, to answer this question, you need to join the two tables together, finding out the DNO 5 and then have additional 4 attributes about those information. So DNO 5 will be able to connect with this one, have research 5, 333445555, and the start date append over the end of the first tuple. So now you can see if you have that huge table, you do have a place to find the research so that you will be able to get the information out of it. And therefore, that's the difference between the two. The first one simply give you department number 5, which you can find in this table. The other question is tell you the research department. And because this is the question asking you about the research department, you need to use exactly the question ask you. Please don't saying that, hey, I know research department is department number 5, so I'm going to convert the second question into the first question. Don't do that because there's a reason we have asking the question saying the research department. It's the same thing. If I'm asking you who is the manager social security number of research department, you can easily get 333445555 from the research department over the first tuple over here. But if I'm asking you who is the manager of the research department, that means I need a name. And therefore, if you're going to simply give me a social security number, that's not going to be good enough. That's why you need to join the two tables, finding out the social security number is corresponding to which name, which is Franklin Wang. So you basically want to attach that Franklin Wang's information in the end of this tuple so that you can use the name out of it. And that's the difference between the two queries. You really need to understand they are very different. One requires a join operation. The other one can be queried in a single table. So the next question is that now if I want to join two tables, how do I know what are the attributes that can be used as the equal join condition? Take a look at this relational schema diagram. It gives you the answers of that. The foreign key, now everything links together. The foreign key is the one that tells you what are the attributes you can make as the equal join conditions. Because when you form a foreign keys, this attribute is referencing another table's primary key. Not only they are referencing with each other, they have the same domain so that they can reference each other. And that's how we will be able to see what are the attributes that can be joined. So you can see that in the employee and department, there are DNO indicating which department they work for. There are manager social security number indicating who is the manager. So you can see that there are like two foreign keys that can be used as the join conditions. And depending on the questions you are interested in, you will be able to find the information that you want. So you can see that when we try to join the two tables, if we want to join the employee table as well as the department table, what we can do is select star from employee and department, where DNO equals to the number. That is going to use this foreign key to join the information. And therefore, when we join the two tables together, we have like creating a big table. Each tuple has their corresponding information with those 15 attributes. Now, saying that I want to find the people who work for research department, I can simply say that select first name and the last name, and you can see that this is the code to join the two tables together. And research name, department name equals to research. In this case, we will be able to find out who are the employees works for the research department. So let's take a look of the code and then try to see, hey, if I want to execute this code, what is going on over here? And you can see that there are 4 people working for the research department, and this is going to be the answers that you will get. One more details about the code over here. A very small detail, if you try to type in research, and the research, the R is happening to use a lowercase research, that will violate the data that you input in the database. So that when we do that, it will not be able to find anything, because the research department, the R is actually a capital R when we input the data. So if you see that, select star from department, and what you can see is that the research is actually in the capital R, administration has a capital A, headquarters has a capital H. Oracle itself is not case sensitive, which means that when you try to write a code for all of those reserved words, those things, they are fine. But if you try to reference the information inside of the table that you provide, you need to use exactly the same words over there. So that is how we will be able to find the people who works for the research department. You are encouraged to try several different things. Find out the people who works for headquarters. Find out the name of the employees who has dependents. Try those things, write your own code, and have a feeling about what is this code going to be looks like. The next one that I want to talk about is we can join multiple tables. So far, we are able to make queries in one single table. We can make queries in 2 tables. Which is like find out the employee who work for research department. It is totally possible that we try to find the information from more than 2 tables, such as 3 tables, 4 tables, or even more. Let's take a look of a question and then see that when do we need to use multiple tables. In this example, 3 is the answer for the number of tables that need to be joined together. So it says that this is the name of department and manager's name where the department has a location in Houston. So that sounds a little bit more complicated. There are several keywords over here. You need to find out the department has a location in Houston. So as a human, we try to find the answer. There are 2 departments located in Houston. One is department number 1, the other one is department number 5. So now I know the 2 department numbers, but you can see the question requires department, the name of the department. So I know I need to join that information with the department so that I can understand department number 1 is headquarters, department number 5 is research. But that's not the end of it. It also needs the manager's name. If it only requires manager social security number, these 2 tables is good enough. However, it needs not only the social security number, but also the name of the managers. That's why we need to have the employee tables as well. So we need to, first of all, join all 3 tables together and then provide the conditions that we want, which is the department has a location in Houston. So first of all, let's see how do we join all three tables together in one code. To join these three tables together, we need to reference back into the relational schema diagram, and you see that department location says D number that referencing the department's primary key, which is D number over here. Since we have two D number using the same name, we need to say department.D number, and this one need to be specified as department locations.D number. So we will need to join the three tables together using this foreign key plus manager social security numbers foreign key to referencing the SSN. You can see that since the MGR SSN is different from SSN over here, they don't need to use employee.ssn equals to department.mgr SSN. Of course, you can still do that, but it's not necessary. So you can see when we try to join the three tables together, we can simply say select star. From department locations, department, and employee, you can see that I put three tables over there now, indicating I am creating a Cartesian product between department locations, department, and employee. Needless to say, when we do that, in back of Oracle, it's actually creating a huge database, a huge table over there, and I want you guys to see that. Therefore, let's have something fun. I'm going to copy this code over here and then pass that code in here. So you see that I'm doing a Cartesian product between three tables. Employee table has 10 attributes. Department has 4 attributes. Department location has 2 attributes. So the new table will end up with 10 plus 4 plus 2 attributes, which is 16 attributes. The number of tuples, it will be fun because department location has 5 multiplies 3 departments multiply 8 employees. So you will end up with a huge table that has 120 tuples. So this is something I want to show you that when we try to do a multiple table join operations, we do Cartesian product of those three tables first, and then we provide our join condition. So you see that there are two foreign keys linked with each other, so I provide a join condition saying that department locations.d number equals to department.d number, and MGR SSN equals to SSN. So we have successfully joined the tables together, and we only get the informations that we are interested in, so that we actually, let me make it slower. So we will be able to get the informations that we have, and then with a much smaller tables that we get. This is a little bit, still a lot of information over here though. So because we can still have all of those number of attributes going to stays over there, and the number of tuples is still not short. So now if we come back to the question, we want to find out the department name as well as the first name and the last name of the managers that location in Houston. You can see that when we try to convert the whole questions, we simply adding, these are only 3 attributes I'm interested in, so that Oracle is not going to give me a huge table that we just see. And of course, the additional information is that the location need to be located in Houston because this is the condition of the query. So now if we add those informations in, and we will be able to get a much easier to read problem. So you can see that research department, Franklin Wang, headquarters, James Boyd, are the answers that we are interested in. So compared with what we see earlier, this is much more understandable. So this is how we would be able to join multiple tables all together and get the information that we are interested in. This slide gives you the same results that I have just showed you. So to make sure you understand what we have discussed today, these are the 2 assignments I want to give to you. First of all, find the name of male employees. So compare with the previous one, which is using the female employee. this is something you need to change a little bit. And then additional condition is saying that who has female dependents. So that the dependents needs to be female. And therefore, there are like 2 additional conditions added in instead of find the name of the employees who has dependents. So use that code as the backbone and then try to add more conditions in and then give yourself some practice. Make sure you will be able to do the first one as well as the second one, which is find the name of employees who works on projects controls by department number 5. So that is something I want you guys to think about and then try to find the answers out of it. And of course, for your convenience, I have attached the table right next to the slide. So you can see that if we try to answer the second questions, find the name of the employees who works on projects controlled by department number 5. So in this case, we will need to look into employee who works on, and it talks about several projects over here. How do I know which project is controlled by department number 5? That gives you the information that you need to reference back to the project, and it tells you what department number controls that project. So you can see that since I give you department number 5, you can directly use the information over here. If I'm playing something more difficult, saying that find out the employee who works on projects controlled by research department. At that time, research department will need to be included. So that will transform the whole question into a 4-table join operation. But for the questions I list in the assignment, because I again give you department number 5, you need to join the employee with works on with projects only. So that is the assignments I want you guys to think about. Write the code, play with it on Oracle, take a screenshot of your code as well as the output of the Oracle code and submit that through Blackboard.